Hello students, in the previous lecture we have discussed about the ionic equilibrium, okay, and in that what compounds can involve in the ionic equilibriums, okay, and later that we have also seen that how can we write the ionic equilibrium constant, okay, that was again very similar to the equilibrium constant, right? Okay, so you see that example also we have seen in the previous lecture how to write the ionic equilibrium constant, okay, and now we are going to start a new topic, that is acids, bases and salts. Okay, already you know what is an acid and what are the bases and what are the salts, okay, you know many things, but again you have to know few things about it. What is an acid? Okay, it has some different um, explanations, okay, right? So first, what is the word acid? Let us see acid. So generally it is derived from the Latin word and it is nothing but acidus, and acidus is nothing but a sour. Okay, you know that most of the acids are sour in nature. Okay, the best example, you know, that citric acid, that lemon, okay, and how the taste will be, that generally they taste sour. Okay, so the acid generally turns the blue litmus paper into the red. You know the litmus paper, right? Okay, so generally the litmus paper, here the acid turns the blue litmus paper into the red color. Okay, so that convert that blue color into the red color, right? And these liberates, generally the acids liberates hydrogen gas on reacting with some metals, like more electropositive metals, like first a group of elements and second a group of elements like sodium, potassium, magnesium, calcium. Okay, so when it is reacted with such electropositive metals, it liberates the hydrogen gas. Okay, and you know best few of the example, the acetic acid, generally it is there in the vinegar. Okay, it is there vinegar, and citric acid available in the lemons, and ascorbic acid available in the orange, that is a vitamin C, and tartaric acid, that generally it is available in the tamarind. It is in the tamarind. Okay, and what is the base? So the base generally tastes the bitter. It tastes the bitter and feel some soapy nature. Okay, so what are the example for the bitter? The best example is the bitter gourd. Bitter gourd, as well as a what is that tooth stick, that palla pulla ఇంటి దగ్గర వేసుకుంటాం కదా. So generally these are the best example for the bases. Okay, and generally these bases turn the red litmus paper into the blue. Okay, this is exactly opposite to the acids. Acids generally turns the blue to the red, and bases turns the red to blue. Okay, right. So these are the basic things about the acids and bases. Okay, and what about the salt? Already you know salt, generally it produces because of the neutralization of the acid as well as the base. Okay, and now there are some different concepts for the acids and bases. Okay, so the first concept is that Arrhenius concept. Okay, so according to the Arrhenius, generally in the earlier stage, okay, that was in the 18th century or in the 19th century, and they defined these acids and bases. Okay, so first defined by the Arrhenius, and how he defined or classified the compounds into the acids and bases is that very simple. According to his theory, what is an acid is that the acid is nothing but a substance that dissociates in water to give hydrogen ions. Okay, that means any substance, if it is dissolves into the water, when it dissolves into the water, something, you assume that a compound, okay, let a compound A is a compound, and when it is dissolves into the water, if that produces NH plus ions, then you can say it is a acid. Okay, right? So the substance that dissociate in water to give the hydrogen ions. Okay, generally the the ionization of an acid, the best example is all the acids when you dissolve into the water. Acids HX, so general type of HX, okay, these dissociate into the water and produces the H plus ions. Okay, do you see the example? So this is a type of an acid, and when it is dissociate into the water, it produces the H plus ions and X minus, H plus and X minus. Okay, so already I told you these H plus ions are highly reactive, so that they cannot leave, they cannot stay like that only. Okay, so immediately it react with the water and convert into the hydronium ions. Okay, if you want write, you can also write directly. So these H2O, H plus ions combine with the H2O and gives the H3O plus hydronium ions. Okay, that is what here is. A bare proton H plus is very reactive and cannot exist freely in aqueous solution. So thus it bonds to the oxygen atom of a solvent water molecule to give the hydronium ions. Okay, so don't confuse when you write like this also, it is nothing but it consists of H plus ions. Okay, right. And what about the base according to the Arrhenius? Very simple. According to the Arrhenius, a substance that dissociate in water to give the hydroxyl ions. Okay, earlier acid gives the H plus ions, and here the base gives the OH minus ions. Okay, so a base molecule like MOH ionizes in aqueous solutions. Okay, let us take best example: sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide. Okay, so these are all on dissolution into the water will convert into the M plus plus OH minus ion. Okay, similarly this OH minus is also very reactive, so that it react with the water and form the hydrated ions. Okay, so like H3O2 minus H3O2. Okay, so you know that the H2O with the OH minus, it will form type of H3O2 minus, and not only the H3O2 minus, it sometimes it also form with combine with the two water molecules like H5O3 minus and sometimes H3O47 minus. These can also exist, but it is in a very less concentrations, Okay, so this is all about the Arrhenius concept. Okay, so according him, so there are some limitations. Okay, because this was the very earlier theory. Okay, so what are the limitations is that it is only applicable for the aqueous solutions, because here he is telling every time what he is telling, when it is dissolved into the water. Okay, so if some compounds even without dissolving into the water also can exist as an acid as well as the base. Dissolve అవ్వకపోయినా acids bases అంటుంటాం. So here those are not describing, వాటిని చెప్పట్లేదు ఇక్కడ, అవునా కదా? So that it is, the limitation is that it is only applicable to the aqueous solutions, right? Okay, and it does not account for the basicity of substances like ammonia, which do not possess a hydroxyl group. Okay, so what he is telling, you take an example of ammonia, NH3. Even though it doesn't have a OH group, it is a base. Okay, what he is telling is that ammonia lanti molecule OH groups లేనప్పటికీ కూడా they are bases. Okay, so these cannot explain by the Arrhenius theory. Okay, and we can go to the next theory, that after that Arrhenius theory, the Bronsted-Lowry acids bases concept came. Okay, what is that? Bronsted-Lowry acids and bases concept. Okay, so how they explained is that very simple again. According to them, what is an acid is that very simple. He forgot about the aqueous solutions, whether it dissolves in water or not. Let us forget. A substance that is capable of donating a hydrogen ion. That's it. ఓకే, సో ఏదైనా కాంపౌండ్ అది కనుక H+ అయాన్స్ని డొనేట్ చేసే కెపాసిటీ ఉంటే, that is nothing but an acid. Acid. Then what about the base? Very simple. A substance that is capable of accepting the hydrogen ion. Okay, earlier OH minus ions, OH plus ions and chepparu. Okay, now here nothing is there. Only simple. If it is ready to donate the H plus ions, then it is nothing but a acid. If it is ready to take the H plus ions, it is nothing but a base. Okay, so that is the reason. Simply you can say that a proton donor, what is that? This H plus ions, you can call it as a proton. So proton donor is nothing but a acid, and proton acceptor is nothing but a base. Okay, so here you see there is a Ha and B minus. On equilibrium it is giving A minus plus pH. So which one is donating the proton? Generally the Ha is donating the proton to the B minus, so that it is donating and it is accepting, so that it is an acid and it is a base. Very simple. It is an acid and it is a base. Okay, and here he explains some more few words. What is that? That is a conjugate acid and conjugate base. Conjugate acid and conjugate base. Okay, so what is this conjugate acid, conjugate base? Is that before going to this, just you look at this one example. Okay, so here you see ammonia on reaction with the H2O, it is converting into the NH4 plus OH minus. Okay, so here you see from where the H plus ions going. Okay, so you see the example ammonia. H2O. Here it is converting to the NH4 plus. That means here it is taking the excess one more proton, and where it is coming from? It is coming from here. Okay, just like this, HOH, and this proton is coming to here. Okay, and what is left here? It is only the OH minus ion. OH minus ion. Okay, so the H plus ion is moving from H2O to ammonia. Okay, and which is donating? H2O is donating, so that you call it as acid. And which one is accepting? The ammonia is accepting, so you call it as a base. Okay, so right here it is the H2O is the acid and ammonia is a base. Right, and what about these two? So for these also he gave a name, that is a conjugate acid and conjugate base. Okay, so what is the conjugate acid? Is that very simple. Whatever that will come from the base is nothing but a conjugate acid, and whatever that come from the acid, it is nothing but a conjugate base. Conjugate base. Okay, so this one is coming from the base, so here he is calling as a conjugate acid, and this one is coming from the acid, so here he is calling as a conjugate base. Okay, so of course it has a very good definitions, but to understand that, simply I am telling that. Okay, what about the definitions? Is that very simple. First, in a reaction you have to identify an acid and base, okay, in a reactants, and then you have to find the species that differs from the acid by a proton, is called as a conjugate base. Okay, you found that it is an acid, and this acid differ by the proton. So where it is differ by the proton? Here, look at here, H2O is there. So this H2O and OH minus. H2O and OH minus ion. What is the difference between these two? Only the H plus ion. Okay, so that means these two are differed by a proton, differed by a proton. Okay, so then if it is the acid, then you have to call it as a conjugate base. Conjugate base. Okay, and what you have to call it as a conjugate acid is that very simple. Similarly, the species that differs from base by a proton is called as a conjugate acid. So first you have to find out the base, and then you have to see that which species is differed by a proton. Okay, so let us see, ammonia is there, and here is a NH4 plus is there. Okay, so ammonia, NH3 and NH4 plus, and these two are differed by the H plus ions, proton, so that if it is a base, then you have to call this as a conjugate acid. Okay, don't confuse. ఇక్కడ బేస్ ఉంది కదా అని ఇక్కడ కాంజుగేట్ బేస్ రాయదు, ఇక్కడ యాసిడ్ ఉంది కదా అని ఇక్కడ కాంజుగేట్ యాసిడ్ రాయదు అన్నమాట. ఓకే, సో you have to exchange. If it is a base, this is acid. If it is acid, this is the base. Okay, right, very simple. So let us take another example. The HCl again on reaction with the H2O, it is forming the H3O plus ions and Cl minus ion. Okay, and here from where the H plus ion moving is that very simple. Here is the HCl is there, here is the only Cl minus. So that means one proton H plus is moving from here to here. Okay, so that the proton donor is nothing but acid, proton acceptor is nothing but a base. Okay, and what it is forming? It is forming H3O plus and Cl minus. And now you found that what is an acid and what is the base. Okay, so first let us see the acid. And for this acid, which one is deferred by a proton? Is it? Here is HCl is there, here is H3O, so no Cl, right? So isn't it? Right, yes, Cl minus. It is deferred by a proton, so that you have to talk it as a conjugate. For this it is a conjugate base. Similarly, the H3O plus ions is deferred by a proton with the H2O. So if it is a base, then you have to call it as a conjugate acid. Okay, are you clear about it? Yes, most probably, right? Okay, if you feel any doubt, you can ask me. So now you have a note that water is acting as an acid as well as the base in different cases. Okay, let us see these two examples. In the first example, when it is reacted with the ammonia, it is acting as acid, and when it is reacted with the HCl ion, it is acting as a base. So that water has a both tendencies, depends on the situation. It can act as an acid as well as the base. Okay, so that in pure water, very little amount of the water can also be ionized and exist in the equilibrium. Very little amount. Okay, how much it is I will tell you, but a very little amount also can be ionized and exist in the equilibrium. Okay, so let us take one water molecule is donating the proton to the another water molecule. ఇక్కడ ఒక ప్రోటాన్ ఒక వాటర్ ఏం చేస్తుంది, ఒక ప్రోటాన్ ఒక దాని నుంచి ఇంకొక దానికి డొనేట్ చేస్తుంది అనుకోండి. ఓకే, సో నౌ it donating, so that here it is H2O convert into the OH minus ion, and this is accepting, so that it will convert into the H3O plus. So here I am writing, here it is shifting. Okay, right? So donating is nothing but it is acid, and here it is accepting is nothing but a base. Okay, so after that again this H2O deferred by H plus ion with the OH minus, so that if it is an acid, this is the base and it is a conjugate base. Similarly, H2O is deferred by a proton with the H3O plus. So if it is a base, it is an acid and it is a conjugate acid. Okay, right. And one more important, very important is that up to now you learned that conjugate acid and conjugate base. Okay, and what here is going to say is that very simple. Let us take strong acid. Just now we have discussed some are the strong and some are the weak, right? I'm going to take two acids, strong acid as well as the weak acid. So you know that hydrogen chloride is a strong acid, and you know that acetic acid is a weak acid. Okay, and you know that HCl directly will convert into the H plus Cl minus, and generally these H plus ions are very reactive, so that it is combined with the H2O and form the H3O plus. Okay, so here I am writing, instead of the H plus I am writing H3O plus Cl minus, and here I am taking that H2O again. Okay, so now it is an acid and this is a base and this is a conjugate acid and this is a conjugate base. Okay, right. So what here is going to say is that you listen carefully, that is, if a strong acid dissociate in a water, the resulting base formed would be very weak. That means here this is an acid, and on dissociation it is giving the some conjugate acid and conjugate base. Okay, so he is talking about this conjugate base. So this is reactive. H plus ions are very reactive, but whatever the Cl minus, are they reactive? No, these conjugate bases are very weak. Okay, and coming to that, again acetic acid, this is a weak acid, and again you know that it can be dissociate when it is dissolves into the water and convert into the CH3COO minus plus H3O plus. Okay, so this is an acid and this is a base and this is a conjugate base and this is a conjugate acid. Okay, forget about the acid. And coming to the weak acids, indake em cheppanu, strong acid lopata whatever the strong acid, when it is dissociated into the water, the resulting conjugate base is a very weak base. Okay, now come to weak acids. So if the acid is very weak and on dissociation into water, and it forms a conjugate base, and this conjugate base is very strong base. It is a very strong base and it is a very weak base. Okay, so that means whatever that conjugate base is coming from the strong acid is a weak base, and whatever the base, the conjugate base is coming from the weak acid is a strong base. Okay, so very simple. Strong acid nunchi వచ్చే base అనేది weak base, అదే weak acid నుంచి వచ్చే base అనేది strong base. It is a very strong base. Okay, so that is what he is going to say. So similarly, a very strong base would give a very weak conjugate acid. Okay, so that means here whatever that Cl minus is coming, right? So this is a weak base so that it cannot react with the water. Okay, but a weak acid dissociate partially in water and give the strong conjugate base. Okay, what is the strong conjugate base? You see that, let us see, HNO2 is a weak acid and it gives the NO2 minus. It is a strong conjugate base. Similarly, HF is a weak acid, on water it gives the F minus. Again, it is strong conjugate base. So these strong conjugate bases, very strong conjugate base. Okay, this gives the strong conjugate base. Similarly, a weak base, ఇందాక ఏం చెప్పాం, weak acids strong bases ఇస్తాయన్న. Similarly, weak bases ఏం ఇస్తాయి, would give the very strong conjugate acids. So ammonia is a weak base, and on reaction with the water it gives the NH4 plus and OH minus. This is a conjugate acid and OH minus is a conjugate base. Okay, so here this conjugate acid is a very strong conjugate acid. Okay, so these are the concept according to the Bronsted-Lowry. Okay, so he explained about that, what is the acid, what is the base, and what is the conjugate acid, what is the conjugate base, and along with that the species, the base which is coming from the strong acid is a weak base, and the base which is coming from the weak acid is a strong base. Okay, and whatever that acid which is coming from the weak base is again a strong acid. Okay, these are the things the Bronsted-Lowry theory explained. Okay, and the next and last theory, that is a Lewis theory. Lewis theory. Okay, so according to the Lewis theory, what is that? Acids and bases is that very simple. A species which accepts an electron pair is called as an acid. ఇందాక ఏం చెప్పాను, ప్రోటాన్ డోనార్, ప్రోటాన్ యాక్సెప్టార్ అన్న. బట్ హియర్ వీఆర్ టాకింగ్ అబౌట్ ద ఎలక్ట్రాన్స్. So whatever that species which accepts the electron pair, you call it as a acid. And a species, whatever the species which donates the electron pair, okay, is nothing but a base. Okay, so what you can write, very simple, electron donor is a base and electron acceptor is nothing but a acid. Simply you can say acceptor is acid, donor is the base. Okay, so earlier proton donor acid ga unde, acceptor base ga unde, but here electron acceptor is a acid and electron donor is a base. So the best example is that all the cations for the acids, all the cations and electron deficient species. So electron deficiency ఎలా ఐడెంటిఫై చేస్తారు? Very simple, in the chemical bonding, when you write the Lewis dot structures and whatever that species deficient with the octet rule, octet rule లో వేటికైతే ఎలక్ట్రాన్ డెఫిషియెంట్ గా ఉంటాయో, so those you can call it as a electron deficient species. Okay, so all the cations as well as the electron deficient species are nothing but the Lewis acids. Example, AlCl3, it is a electron deficient, and CO3 3 plus H2CO3 I don't know. So Bf3 and magnesium 2 plus, these are all the Lewis acids. Okay, now whatever the base, already I told, whatever that species which donates the electron pair. Okay, so what can donate? All the anions can donate the electron pair, and the lone pair containing species like H2O. Generally H2O contains the 2 lone pairs and ammonia contains the 1 lone pair, and OH minus, already it is a excess minus anion. So that all these things are the Lewis bases. Okay, next you see that the Bf3 NH3. So Bf3 is electron deficient and NH3, generally nitrogen contains the excess electron. So that these electron pair donated to the Bf3. Okay, so that here it is a donor, so it is a base, and here it is an acceptor, so that it is an acid. So it is nothing but a bond between the Bf3 and NH3. Okay, so this is about this lecture, and in the next lecture we are going to the other topics. Generally you have some ionization constant of the water, as well as the ionization of weak acids, ionization of the weak bases, and ionization of the buffer solutions. Okay, but these, what I came to know is that these topics are excluded and removed because of the 30% reduction of the topics, right? And next we are going to see that solubility of some salts, in the next lecture. Okay.